But there's also a different experiment that has a different link. So now this is going to correspond to a different setup. So for part C of today's lab, this is going to correspond to an inclined plane. So let's see what happens when a block is stationary on an inclined plane. So this is the block here. It has a mass m. So let's see the forces that are acting on it. First of all, gravity is acting straight down, and the normal force is acting perpendicular to the surface. And in this case, friction is going to act upwards along the surface. And there's also going to be, this incline is going to have an angle theta. And so here, we again want to calculate the coefficient of friction on the inclined plane. So if we do the free body diagram, I'm going to just do this quickly here. I'm going to call this my vertical, I'm going to call that my y-axis, and I'm going to call this the x-axis. So from there, the weight is going to get broken up. This is going to correspond to the x component of the weight, FGX, and this is going to correspond to the, oh, excuse me, I said it incorrectly. This is going to correspond to the y component of the weight here. So let me just redo that. So along this direction, this is going to correspond to the y component of the weight, FGY. And along this direction, this is going to correspond to the x component of the weight, FGX. And we can solve for those components in terms of the angle. So if this is theta, then here this is 90 minus theta, so this brings you back to theta here. And from there, the y component, FGY, is going to correspond to mg cosine theta, because that vector is adjacent to the angle. And the x component is going to correspond to mg sine theta. But more than that, this block is moving down the incline. It's not moving off of the incline. So that means that the y component is going to equal the normal force. So then this is going to equal Fn. And the x component, we're going to assume, well, here it's stationary. So that means that the x component is going to equal friction. So for part 3, what we're doing is we're also again going to calculate the coefficient of friction, but in terms of the angle of the incline. So the basic equation for friction is equal to the coefficient times the normal force. And there we can substitute those two terms that we just got. So the friction is equal to mg sine theta, and the equals the coefficient, and then the normal force is equal to mg cosine theta. So there, notice that the mass and the weight just drop, and we can solve this for the coefficient, and you get that the coefficient of friction is equal to sine of the angle over cosine of the angle, or is equal to the tangent of the angle. So this is what you're going to verify for part 3 of today's lab, is that just by measuring, so there's going to be an inclined plane. Let me be clear here. So you're going to have a block on the surface, and you're going to elevate the incline, so to a particular angle, and you're going to find the angle so that right when it just begins to slide. And there, just by knowing the angle, you're going to be able to measure the coefficient of friction. In this case, this is going to correspond to the static case. So part 3 then, what you're going to do is you're going to, for a series of masses, so you're going to have a table, and for a series of masses and a series of angles, you're going to elevate the incline, and from there you'll be able to calculate the coefficient of friction by simply calculating the tangent of the angle. And that'll complete the lab. So this lab is broken, there's 3 parts, but part 1 and 2, part A and B are similar. So for part A, what you're doing is you're going to make a plot of, you're going to pull a block in the horizontal direction, and you're going to make a plot of friction versus the normal force. And from that, you'll be able to calculate the coefficient of friction. And this is going to be for part A and part B. And part C, this is going to be done on an inclined plane, and you're just going to elevate the incline until the block begins to slide. And once it slides, you're going to record this angle, and that is going to also correspond to the coefficient of friction. So this completes the explanation for the friction lab.